Floating bodies, part 4. Let us perform a simple activity to see what happens to the weight of the substance when immersed in a fluid. Take a piece of stone and tie it at the end of spring balance with the help of a string and note the reading in spring balance. Then immerse the stone in a glass of water and again take the reading in the spring balance. You will notice that there is a decrease in the reading, which means that there is decrease in the weight of the stone also. It is because there is an upward force acting on the stone. We know that this upward force is known as buoyant force. But what is the magnitude of buoyant force acting on any substance? The answer to this question was found by a Greek scientist, Archimedes. Archimedes found out the answer when he noticed that the water in a bathtub overflowed when he stepped into it. Archimedes shouted, "Eureka, Eureka," meaning "I have got it," as he ran through the streets. Archimedes' principle states that when a body is partially or fully immersed in the fluid, then an upward force acts on the body which is equal to the weight of the fluid displaced by the body. Archimedes' principle is applied in various cases, like in designing ships and submarines. How did Archimedes solve the king's problem? The crown and a bar of gold of the same mass as the crown are suspended from the two arms of a simple balance as shown in the figure. If the crown is less dense than the gold bar, it definitely possesses a larger volume than that of pure gold and will displace more water and thus experience a larger upward buoyant force, causing the balance to tilt towards the gold bar. This would indicate that the crown was not of pure gold. Pascal's principle. Pascal's principle states that external pressure applied to an enclosed body of fluid is transmitted equally in all directions throughout the fluid volume and the walls of the containing vessel. Here we have an enclosed volume of fluid in a U-shaped tube. The fluid is enclosed in the tube by two leak-proof pistons in each arm. The ratio of cross-section areas of the right and left tubes is A2 is A1 and A2 is greater than A1. When a force F1 is applied to the left piston, the excess pressure acting on the fluid volume is F1 by A1. According to Pascal's principle, this excess pressure is transmitted equally throughout the fluid volume. That is, every unit area of the fluid experiences this excess pressure of F1 by A1. The excess pressure in the right side tube is also F1 by A1, and since its area is A2, the upward force acting on the right piston is F2 equals to A2 into F1 by A1, which is much larger in magnitude than F1. Thus, the application of Pascal's principle results in a larger upward force on the right piston when a small downward force is applied on the left piston. This principle is used in the design and working of hydraulic jacks or lifts, which you can see in automobile workshops. A small downward force applied by the hand of the operator helps to lift a heavy vehicle with ease.